3 gram of hydrogen. If you have the question in exam, in multiple choice, which one is the limiting reagent in this reaction? You might think, hey, I got nitrogen, it's less than other one. The same problem you have in here. When you saw the cheese and bread, you might thought, hey, I got it. But the cheese is the one limiting, is it? No, this is the bread. You know, how do you know? After making sandwich, then looked at the bread and which one is ran out. Same here. So you start making sandwiches, start making product from both reactant. So 2 gram of nitrogen, and then gram, you always go to the mole of nitrogen. Then, so 1 mole of nitrogen equal to, we did that today, 28.0 gram of nitrogen. And then you can use bar as well. I'm showing all different options, guys. And then 1 mole of ammonia. So one mole of nitrogen is producing 2 mole of ammonia. So now we can see how many mole of ammonia you're producing. If you want to calculate to the gram, you do one more step. It's up to you. So if my question is, depend on the questions. If question asking how many mole of ammonia you're producing, or it could be asking how many gram of ammonia, or how much ammonia you can get in gram from 2 gram of nitrogen, 3 gram of hydrogen. So if it is gram, then you do one more step. Then 1 mole of ammonia equal to, so 17.0 gram of ammonia. So 2 times 2, 68 over 28. 2.42. 2.42 gram of ammonia. Then you compute the other one. You try with a bread, now you try with a cheese. So 3 gram of hydrogen, 1 mole of hydrogen equal to 2.0 gram of hydrogen. Is it going to be 1 gram or 2 gram? What is the mass of hydrogen? 1, but since it's diatomic, there will be 2. Right? Again, you can use bar or multiple sign. So 1, so mole of hydrogen, which is 3 mole of hydrogen in the reaction. So when you multiplying the coefficient you take from the equation. So 3 to 2. So 3 mole and then 2 mole of ammonia. Then in the last step, since we go into the gram, then 1 mole of ammonia will be 17.0 gram of ammonia. So just as a recall, just reminder, how do you know which one will be top? Depend on what you're calculating to. What is going to be the bottom? Look at how you calculate with the previous one. To calculate to cancel out with the gram, put gram here. Cancel out mole of hydrogen. Mole of hydrogen, you have to be in the opposite side. The same way, mole of ammonia, you put mole of ammonia here. Then gram in the top, because your goal is to calculate gram of ammonia, how much you can make from this amount. So So 3 times 2 times 17 dividing by 3 times 2, 6. So 17 gram of ammonia. So remember, I give you another example, race of this class. So I am the one who is going very low speed. So the compound, the reactant making small amount of the product, that's called the limiting. So here nitrogen is the limiting because that's making smaller product than the other one, 17 and then 2.4. So nitrogen is the one limiting, and the question is how much ammonia will be producing here? What is the race of the class? Depending on what is the race was mine. What was the product of this reaction? The product from the limiting one, not the 17. One tricky question. What is the difference between these types of problem than the earlier one we solved?
In the middle there's a mole-to-mole conversion.
Second, speak up.
In the middle there's a mole-to-mole conversion.
Exactly it is. In the middle, mole-to-mole conversion that we did not have before. Right? In previously we had 3 steps, remember? Gram to mole, mole to the gram of other one. Here gram to mole and multiplying with the coefficient to get, and then second difference, one more difference is. What is the other difference? The other difference is you have 2 reactant given. The other one you will have just only if you need to calculate how much ammonia is producing from 2 gram of nitrogen. Very simple step, very simple, right? Whenever you have 2 reactant given, then you need to calculate from both reactant which one giving less product than other one. That would be the right product, and that's the limiting reason that you're starting off. Any question? Okay. Look at another example you have here. Nitrogen, hydrogen producing ammonia, and then this ammonia, when you look in a jar before the reaction, you might think, hey, I have a lot of hydrogen left. But it's not, because you need more hydrogen in the reaction. Based on the stoichiometric ratio, hydrogen is much more than nitrogen. Then you see, you have leftover. What is the leftover of the reaction? You have, if you look at this one, you have leftover is the nitrogen, not the hydrogen. You might thought, hey, I have a lot of hydrogen, but actually nitrogen is the leftover because you need much more hydrogen than nitrogen. Okay, then we could move on to this very simple problem. Please solve this one. Who want to volunteer? Anyone to volunteer the board? Yes?
I'll try.
Okay, do that. Is it possible you can do it here?
Try and do it, but that's going to be hard to read.
It's fine. Do one here. The reason is so that you can.
91.224.
Yeah.
Anybody else have a question?
This was somebody was texting me last night, like, how do we do this? No, we did. Good thing we didn't quiz on it, because that was weird.
Actually, you have zirconium mole, right? And then you just need to calculate the mole to mole ratio. Because in this problem, if you look at this one, this problem you have the mole, right? Let me show it here. So, other one started off gram. This one already in the mole.
So you don't need it.
You just need to multiply mole to mole ratio.
Okay.
Knew it. I was right last night. I was like 45 minutes watching this.
So then magnesium mole is
Hell yeah, right.
I get it wrong because I was ready.
Yeah, because it was like, yeah, it's just the ratio. But if it was on grams.
so 2 gram magnesium will be producing 1 mole
Right,
zirconium.
since we already have moles.
So and
That's our elimination.
this is going to be,
Possibly.
so zirconium is going to be on the top in here. So 1 mole zirconium
Oh yeah. 550. Let me see if we can grams.
and
Well,
You can't
You're
go
right.
higher. You can have a higher number than 0.2.
yeah, but that's only because the weight, the amount in the 0.2 moles is.
so how many mole of zirconium metal you can produce? 0.25 or 0.20? Why 0.20?
You can't have.
I can hear you.
You can't go higher.
Because it's
Smaller
all
than other.
reactant.
The one is smaller, one.
Right.
The product is small amount, smaller, that will be the limiting reagent. So here, zirconium chloride is making smaller amount of metal than the magnesium. So this zirconium is the limiting.
Can you go back?
Sure.
Okay.
Okay, the last thing we'll be learning in this chapter is, this is another problem you can practice at home. I'll be posting the PowerPoint, this PowerPoint for you, so you can look at it. The last topic in this chapter is theoretical yield. What is it?
How much you can theoretically get out of one reaction.
How much you can theoretically produce, right? In the experiment, in the reaction, practically, no, it's theoretically. Look at that, what you have been doing, all theoretical, not practical, not the actual one. Actually, you cannot get exactly what you get in theoretical. There is no experiment, no reaction is 0% error, right? Is it possible? You want to make ammonia, right? So you don't get exactly 2.4 gram if you really use 2 gram of nitrogen. There will be always certain amount of byproduct. Some compound, some reactant must be wasted. That's always happen. So the actual yield always will be different than theoretical yield. Question: is actual yield is going to be lower or more than theoretical yield?
Lower.
Always going to be lower, right? Because you don't get you get less than what you expect. Wonderful. And in practical life, maybe if you want to get GPA 4 out of 12, you may be able to get 4 out of 4. But in experimental part, in chemistry experiment, you don't get 100% product. Always lower than actual. So other important thing is always have to be in a gram. Actual and theoretical always have to be in a gram. And the formula is this one. Percent yield is actual yield over theoretical yield time 100%. Right? So if you need to calculate theoretical yield, you have a reactant, how you calculate? This way. Now you did. And how about the actual one? Can you calculate actual one from the theory? From the equation? No, you cannot. Because actual one always going to be given for you to calculate percent yield. Again, actual always going to be given, but theoretically you need to calculate the way you have been calculating from the reactant or limiting reagent. Then multiply by 100%, then you get percent yield.
Just divide by the grams?
Yes, gram over gram. So that will be no unit then, right? Yes, just the number. So the step, if you go, exact step is write balanced chemical equation, then convert masses to mole that you have been doing, and then mole to mole stoichiometry ratio. Then finally, you get the product which you calculate actual or theoretical multiplying 100%. Can you do this one? You have ammonia and carbon dioxide. You making urea, right? So number one, calculate theoretical yield of urea, and then percent yield. How do you do that? Do you know how to calculate theoretical yield? Exactly, it is. Look at that. Consider this is your ammonia. This is your carbon dioxide, right? Exactly, it is. Start from carbon dioxide, start from ammonia, both. Look at that. Which one is giving you more urea? Which one is giving less urea? Then you look, you decide which one your theoretical yield. Actual yield is given, right? Then you calculate that. Can you do that, please? Everybody do that. I want everybody to do that. Yeah. Yes, it is. So you have a help in here. Help is limiting is carbon dioxide, right? So not necessarily always will be given like that.
So you could just
Do the carbon dioxide one.
just the carbon.
Yes. So you don't have to do two calculation, right? Only with carbon dioxide. If not, then you will be doing one for ammonia, one for carbon dioxide. That one is given less product, that will be limiting, right? You got to help. Molar ratio,
Oh, it's over there. Oh.
One-on-one. Okay. Okay, who wants to get extra point? Yes, go ahead.
Who's on it? I know.
Yeah, that's why I'm looking at it.
Yeah, sometimes it's hard, mine isn't.
But here, we will affect you one six, why it didn't work out.
This, I don't learn that way, so I'm gonna do it.
Oh, I can, oh, but this is like, this is branches, so. This is all right here, yeah. This is so happy, what is
Would you like to calculate mass of urea first?
92.07, I believe.
Okay.
Does that sound right?
Formula mass of urea. So if you want to make carbon dioxide cancel out, then write carbon dioxide in here. You're right, mass was okay. So 44.0 gram.
That's where I started.
You're right, you're right. And then 1 mole of urea. So CH4N2O. Everybody cannot see the top? That is CH4N2O. Okay, that's the theoretical yield, right? Guys, who can do number 2? Number 2. Number 2? Yes, go ahead. Giving chance to more people.
Good one.
Percent yield is actual over theoretical. Formula first.
That's 13.6.
That's 68%.
Is that correct?
Yes.
Wonderful. So next class will be the quiz 3 on chapter 3, and we'll have a review for test 1. And the next quiz will be exam 1, right? Okay. I'll see you guys on Thursday. Okay. Sounds good. Yes, sir. Reviews will be Thursday, and following Tuesday will be exam 1. 11 Thursday too. Yes. No sample quiz. Sample quiz, yeah, you have. At in the PowerPoint has at least 4 sample questions.
Can be my chart one, I guess.
You can follow them. That would be good enough. Yes,
I
ma'am.
know I passed, so.
Yes, ma'am.
Can I get my charger? That's what I.
No, you cannot. You give it to me, no?
That's my only charger.